Solve the quadratic equation for x using the quadratic formula. Before we can use the quadratic formula, first we have to write the equation in this general form of a quadratic equation, meaning we need to multiply everything out and then set it equal to 0. So we'll start by distributing this 2x into the parenthesis to get 6x squared minus 2x, and we're still equal to 3 on the other side. Then we'll need to set it equal to 0, so we'll subtract 3 from both sides. The 3's cancel out on the right-hand side, and the negative 3 is not a like term with any of the terms that are already on the left, so we just copy-paste it down and write our terms in descending order, which means that the highest power on the x goes first, the next highest power is next, and then the constant is last. When the quadratic equation is set to 0 and written in descending order, this is when we can determine who the values of a, b, and c are. A is the coefficient on x squared, so that's going to be positive 6. B is the coefficient on x to the first power, so that's going to be negative 2 in this scenario. And then c is the constant value, and in our case, c is negative 3. Now we're ready to plug these values into the quadratic formula, and we'll begin by writing down x is equal to. Remember, x is equal to is how the quadratic formula begins, and we do want to anchor the left-hand side of our equation with that quantity just to remind us what it is that we're finding so that we don't get lost in the process. So we start off with negative b, or this could also be interpreted as the opposite of b, which is actually preferred, especially when our b quantity is already negative. So in our numerator, we're going to have the opposite of b, and that value is going to end up being a positive 2. And then we have plus or minus the square root of. B squared is our next quantity, so when we plug in our b, we're going to need parentheses to ensure that the entire value of b is getting squared. Again, our b quantity is negative 2, so those parentheses are necessary to make sure that we're squaring the negative as well as the 2. And then we are going to subtract the product of 4 times a times c. So we'll subtract the product of 4 times a times c, and the a quantity was 6 and the c quantity was negative 3. All of this is divided by 2 times a, and again the value of a was 6. So now our task is to simplify this quantity. We'll start with the opposite of b, which is the opposite of negative 2, which is positive 2, plus or minus the square root of. Here we have negative 2 quantity squared, that's going to be a positive 4. And now from that, we're going to subtract this product. And this product is going to be a negative quantity, so we're going to be subtracting a negative. When we subtract a negative quantity, that ends up being addition. Notice that when we have 2 minus signs here in this product, we're going to end up with addition under the radical. So we're adding 4 times 6 times 3, which is 72. And in the denominator, we have 2 times 6, which is 12. So now we're continuing to simplify, and when we wrap around to the next line, let's anchor the left-hand side with an x is equal to. So we have 2 in the numerator, plus or minus. The square root of 4 plus 72 is 76, all over 12. And let's take a moment to look at the square root of 76. 76 can be factored into the product of 4 times 19. And since we have multiply under the radical, we can split this radical into the product of 2 radicals. That's going to enable us to take the square root of 4, which is 2. And then since the square root of 19 is not an integer, we're going to leave that 19 underneath the radical. So square root of 76 can be reduced to 2 times the square root of 19. So we're going to replace rad 76 with 2 rad 19s. And we're still all over 12. Now notice that we can still reduce this even more. Both of these factors of 2 will cancel into that 12, but we can't cancel over add and subtract, so what we need to do is to split that numerator, each one getting its own denominator of a 12, and then reduce each of these individually. So we have a common factor of 2 here, so 2 goes into 2 once, 2 goes into 12 6 times, and we can cancel over multiply. Again, we'll say 2 goes into 2 once and 2 goes into 12 6 times. So our final solutions are going to be 1/6 plus or minus just the square root of 19 over 6. These actually count as 2 solutions, 1/6 plus rad 19 over 6 and 1/6 minus rad 19 over 6. So we'll use a graphing calculator to check these answers and begin by choosing alpha and F1 here in the top left-hand corner to gain access to the numerator-denominator feature that enables us to put in a fraction more easily. So we have 1/6. Now we can only check one of these at the time, so I'm going to choose the plus. Again, we'll have alpha F1 to get another fraction. Numerator denominator is accessed by just hitting enter when my cursor is next to that first function. In order to put in the square root, we have to hit second and then this button to get the radical feature. We have the square root of 19, and that's divided by 6. We come out of here and we want to store this quantity using the store function into x, and then we hit enter. So now that we have one of our answers stored into the x variable, we can go back up to the beginning equation and we can simply type exactly what we see here into the calculator. So on the left-hand side, we have 2x times the quantity of 3x minus 1, close the parentheses, and then we want to hit enter to see what the left-hand side is equal to. The left-hand side is equal to 3, the right-hand side is also equal to 3, and so our plus solution does work. Now let's run this through again, also checking our minus solution, but instead of having to type all of this stuff back in, I can hit the arrow button to climb up to the previous solution, and then once I've highlighted that previous solution, I can hit enter in order to paste it down into the working field. That will then enable me to go into this value and change that plus to a minus. Now I can hit enter again and I have stored the second solution into x. Now I want to run the equation through with this second solution in it. So again, I'm going to go up, up, up a couple of times until I get to the left side of the equation again. When I'm highlighting this, I can hit enter and it's going to paste it into the working field. Now I can hit enter again and it's going to reevaluate this left-hand side, but with this new quantity stored in for x. So just hitting enter again says that this is also going to be equal to 3, so both solutions plugged in for x gives me an output of 3, and therefore both of those solutions work.